Welcome to the Sports Science Dudes. I'm your host, Dr. Jose Antonio, with my co-host, Dr. Tony Ricci. You can find us on Spotify, Apple Podcasts, and YouTube. Our special guest today is Dr. Darren Candow. Dr. Candow is a full professor. He's the past Associate Dean of Graduate Studies and Research. I can't imagine how much fun being a dean is. Supervises the Aging, Muscle, and Bone Health Lab in the faculty of Kinesiology and Health Studies at the University of Regina. That is in beautiful Canada. He serves on the editorial board for Nutrients, Frontiers, the Journal of the International Society of Sports Nutrition. He also serves as a sports science consultant for everybody. He is the expert. Now, the best news, though, I'm not even sure Tony's aware of this, but Dr. Darren Candow will be the Harris-Holtman keynote speaker at this year's ISSN conference. Woo!
We like that. All right.
Yes.
In Bonita Springs, by the way.
That's right. Yeah, an amazing honor. Thank you.
So we are very happy to have Dr. Candow back on the show. And before we start, tell us, we get in some of the creatine stuff. Tell us about, you just attended a Sarcopenia conference. I'm sure you'll address this, but my difficulty with the Sarcopenia field is I've yet to see a definition that says, hey, you're sarcopenic.
Yeah.
So tell us about the conference.
Yeah, this conference goes on annually. They always switch it from Europe to some place in the United States, and this year was in Albuquerque. And they literally just came out with a new consensus definition, to your point. It came out yesterday, over 107 different bodies, and nothing's really changed. It seems like the majority of the definition, if you will hinder on muscle strength, then muscle mass, and we can get on the nuances of actually determining that. But then they actually added in a third category, which is a little surprising, sort of regional or relative muscle size in relation to strength. So that sort of refers to as muscle quality. They've taken functional ability out and sort of now are considering that as a symptom of poor muscle strength and mass. It used to be in there, but performing activities of daily living, that's probably a product of low muscle strength, which is associated with muscle mass. But this conference is fantastic. They bring in all the heavy hitters, and again, they sort of go against the BIA and the DEXAs and all that because we're measuring lean, and it's almost near impossible to measure muscle mass, but they're really starting to promote MRI in combination with this D3 creatine. It's probably a way to do it. I sort of still support the DEXA because at the end of it, even if half of it is muscle, you're still seeing some change. Highly likely that organ and bone and that will change, especially as we get older. But if an older adult, puts on 1.5 kilograms of lean, even at a rough estimate, if that's 700 grams, that's a lot of increase. Keep in mind, we're losing. So if we can halt that process, so it is, I understand the nuances, but it's something for our graduate students and undergrads to accept when they go on the InBody or the DEXA. There's always a bit of caveat. And without doing an autopsy, even with MRI, there's going to be a little bit of a trade-off. So that's something to consider.
So age is not part of the definition, age-related loss of skeletal muscle mass and strength. You could be sarcopenic at age 30?
Yeah, they're actually saying now that age number is sort of not as important because look at some of our university students. Inactive, not really performing activity, poor diet, they could actually have some biological traits of aging muscle that we never thought was possible. So again, the age is still there, but it's now becoming a global idea looking at all age ranges.
So Dr. Dan, so actual skeletal muscle or the actual cellular loss, even at that young age?
What we're starting to see is the inactivity can cause a whole catastrophic events. It's called a disuse atrophy. And, a lot of individuals who are completely sedentary, look what happened to COVID. In Canada here, the government says you can't go outside, you need to stay at home. And so people were forced to be inactive, even if they were able to go outside. And then you look at some areas of harsh winters and things like that. But obviously, starting in the fourth decade, accelerating, fifth, sixth, seventh decade is when the biological process really occurs. But around the start of that fourth decade, Elena Volpe actually showed some really good data that we don't need to wait till the fifth or sixth decade. These processes are occurring. And the big new thing is we've kind of had an idea about sarcopenia, all the muscle fiber loss and hormones, but this low-grade inflammation is really coming to the forefront where we're having these cytokines in the blood. And it kind of makes sense when you ask someone in their 40s and 50s compared to their 20s, they're like, God, I'm hurting myself more. I can't lift nearly as much heavy weight. I seem to be taking Advil more just to get through the day. And it's this low-grade inflammation that we start to see as being a main factor in this catastrophic loss of muscle and or strength. Yeah.
Yeah, now, we have operational definitions for a variety of things, and whether or not we agree with them, at least there's a definition. Like, for instance, if your BMI is over 25, you're supposedly overweight.
Right.
So in terms of strength, how low does your strength got to be before you're sarcopenic? Now, I do mostly upper body exercise because that's what paddling is. Is it possible, because I wrote down in my notes, you're talking about regional muscle mass and strength. Is it possibly sarcopenic in one region and strong in another? I mean, I could see that happening.
Yeah, that's 1,000,000% correct. So this is interesting that the global measure is still the hand grip. So you look at the amount of muscles and anatomical areas involved, and it's highly correlated. There's been a few new studies come out that maybe lower body, like leg press or whatever, is a better surrogate because we're losing those greater muscle fibers in the leg. But they simply use either chair stand, which they consider a measure of strength. But hand grip seems to be the global measure. It's easiest, cost efficient. But you're right. You would think of someone in the Tour de France, lower body, highly endurance, strength, upper body. Why would they need to worry about that so much? But there's now a push that I personally think lower body is more important than upper body because the larger muscle groups are atrophying. But getting off the toilet, carrying groceries, doing things still require upper body strength. So I like to look at it from a global perspective. But you're right, you could have segmental areas, and that could be catastrophic. Yeah.
But then the question is, when are you sarcopenic? I guess I'm trying to get to the definition. I mean, BMI over 25, you're overweight. Okay, we may or may not agree, but at least there's a definition.
Yeah, they're approaching now just north of 20 kilograms of strength in both hands for the hand grip. But we don't really know calf, quadricep, things like that. So it's a low threshold. Usually it's having a hand grip strength of 20 kilograms or more is the minimal or the barrier for sarcopenia.
That's for men and women?
It would range a little bit more for men, but that is the low point when you're diagnosed with sarcopenia. Gait speed is 0.8 meters per second. And then lean tissue, we just don't know because we can't really measure exactly what's happening.
Tony, I'm sure you've done a lot of hand grips in your labs, and I'm telling you, there's a lot of college-age women whose hand grip is not 20 kilos.
Definitely not. As a matter, I do it a lot in fighters. It's not used a lot in fighters, but I think it's a valuable tool, actually. But yeah, we do the grip dynamometer. Dr. Janine does it more now, but nevertheless, I've had a lot of people not reach that, to be honest with you. Yeah.
And keep in mind, those numbers are primarily based on adults, in their 4th or 5th decade and above. To have the numbers relevant down to a young age is very difficult to extrapolate. I think what's going to happen is the percent change. Where they start, let's put them on an exercise program, high protein, and then see if they can improve over time. But the hand grip is very isolated movement. I know it's correlated with a lot of functionality and comorbidities, but it's a very unique tool. If you've never tried it, it's, squeezing isometrically on this hand grip. If you're not used to it, it's very odd. But if you put a young female under, a squat or a leg press, they're probably going to have a lot greater strength because it's more specificity.
Right. Yep.
It's very interesting to take our athletes and say, we want you to grip this isometric device.
Yeah.
And they're like, geez, I'm always underestimating because I'm not used to it. So that's a caveat. It's a measure, but I think looking at the percent change over time is way better. Yeah.
Yeah. And you have guys on social media that argue over, the best predictors of longevity, and we're sort of digressing to another area, but this is kind of interesting. So you can use hand grip, which is, it's a basic measure of functional strength. And some people say VO2 max, which is now you're doing something else. So I know Peter Attia, he loves saying, well, max VO2 is the greatest predictor of longevity, when, to be honest, I don't even know my own max VO2. Tony, I don't think, have you ever measured yours? I have no idea.
I have, actually.
Yeah. So most people,
nothing to be proud of.
Yeah. And I would totally disagree with that. I mean, how many people go in and choose their max VO2 when they're unaccustomed to it? Yes, that'll measure the amount of oxygen coming in, but we have way better biological markers that you can now profile. That's like saying your bench press 1RM is the best predictor of longevity. I mean, that's all a caveat, yeah.
Right. Yeah, because by the way, Tony, what was your max VO2? I'm curious.
I was now 49.
Hey, that's not, you know what? I bet
Yeah.
you're higher than a lot of your students.
Yeah.
Well, I would say this, for my body weight, I think it's pretty good. I'm not, let me be, you know what I'm saying? When I stretched 5'7", 211 pounds and, you know, a 30-inch waist. I mean, I don't think that's a good VO2 build, but yeah. So if it is according to VO2 guys, by the end of this podcast, you'll be reading my last rites.
And it's interesting, although it was a Sarcopenia conference, a big emphasis was on the mitochondria, which is primarily aerobic based. Here we have Sarcopenia. We always thought lifting weights was the only thing. And now a lot of new research is suggesting the mitochondria is really implicated in predicting longevity. So maybe not VO2 peak or max, but it's that cellular aspect, telomeres, reactive oxidative species. And so the question comes, what's the best form of exercise to increase mitochondria? And if you look at the data, it's aerobic. It's not resistance training. Both are good. But then we look at this low load, high volume training, which is kind of like resistance training cardio, especially for older adults. Could that lead to mitochondrial biogenesis? But one of the hallmark things from this conference was that how the emergence of the mitochondria is really predicting mortality, morbidity, falls, and fractures. And it kind of makes sense. This organelle does everything, right? Successful aging, it sort of spits out reactive oxidative species, creates ATP. We'll talk about creatine, it shuttles it. So it's one organelle we've all heard of for the ATP or powerhouse of the cell, but when we think of sarcopenia, we always just thought of weightlifting. But if we can do both, I think that's the biggest prescription we can take home is you got to do cardio, you got to do weight training, and that's going to be the fountain of youth, I think.
Well, what if you do an exercise, like I talk to a lot of rowers, and for people who've actually rowed in a race, you'd almost have to admit there's a resistance training component.
100%.
And I paddle out here in the St. Lucie River, and oddly, I never see paddlers, but I see rowers, like single rowers. And to me, I'm thinking they're using their legs, they're using their upper body. Is that not sort of a combination of aerobic training with resistance training?
100%. If you look at their body, they're extremely muscular, strong. Their endurance is off the chart. If you were to do a biopsy, their mitochondria would completely fill the size of the cross-sectional area. So if you look at some of these athletes, like the resistance against wind, current, and absolutely. So it's a form of concurrent training, but you're sort of getting everything out of it. And I'll be honest, if you put me on a rower, I'm gassed in about 4 minutes because of the resistance. And I'm like, geez, that's really, really difficult. It's kind of like doing a wind gate. You put resistance on and it's really, really daunting. And I agree. Anything that you can add in resistance to a cardio or overall longevity is probably better off for you.
So you're giving the Harris Holtman keynote at ISSN. Again, the conference is June 18 to 20. The website for it to register is issn.net. That's issn.net. Can you give the audience a little sneak peek? I know there's new stuff coming out with creatine. It's sort of like, if you go back 15 or 20 years, my advice was always, hey, take 5 grams a day. It's great for your muscle. You'll saturate it. You'll be a little stronger. It might help your brain a little, but there's really new stuff coming out, and it's really kind of fascinating.
Yeah, I'm super excited. So I've titled it The Evolution of Creatine Research. And to your point, I think we're going to sort of open the door and look at all the new areas, including dosing, frequency that creatine has sort of been looked at. And it was originally designed to be for bodybuilders and athletes. And now we're going to start to look at, does the tissue of your body dictate how much? What are some of the benefits? So we're going to go all the way back to 1832 and look at the pioneers, and then we're going to go to all the other areas. So I think it's going to be super exciting. I've started to work on it already because I really want to sort of bring in all those new facets. Like, when did we ever think pregnancy or children would come into the realm of creatine supplementation? What about concussion and depression? So it's taken on a whole evolution, not just for getting bigger, stronger, faster. So I'm super excited to sort of put it all into a nutshell if I can, yeah.
Very neat.
Is there population data on who consumes the most creatine? What country, what nation?
To my knowledge, Serge Ossiak would have that. He's put out a few papers on dietary creatine. I don't know. My guess is the Scandinavian countries with the high seafood content. But I'm not off the top of my head. I don't know the country that would lead that. Then you would bring in Asia. My God, seafood would be the highest concentration
Right.
here. So I don't know. Those are the two areas that come to my mind. Yeah.
Yeah. I mean, I don't know either. I've always guessed that it's
Mhm.
Japan only because Japan, but again, Japan, the population of Japan exceeds all of Scandinavian countries
Yes.
combined. But
Yeah.
they consume 20% of the world's fish.
Yeah.
That's a lot of damn fish.
A lot of
And
fish.
a lot of it's top water and speed fish like tuna and
Yeah.
I mean some bottom, but a lot of it's more of those fish with the higher creatine loads too. So
And another big thing is now with the huge focus on plant-based diets, vegans, vegetarians, it's almost becoming a push now that creatine may be considered essential for certain individuals if they're not getting enough. And there's been some papers now looking at just your dietary creatine. If it's not getting a substantial amount or a minimal amount, could that be impairing your not only performance, but what about cognition and brain function? And you know, I always think of now with the Paris Olympics coming up, athletes may be taking creatine for performance, but what about late in the quarter? You know, the mental clarity and focus and fatigue is going to come to that. And I think creatine is something to at least consider. And I'd be shocked at the Paris Olympics if not a lot of athletes have heard it or at least considering taking it, not for the performance, but maybe the cognitive and mental acuity effects. Yeah.
Tony, do you take creatine? Or
I do. Yeah, I use low dosing, no more than 5, and I know that the cognitive benefits. I think Dr. Darren and Dr. Scotty Forbes, you know, they want 10 or more. The only problem with that is I am a high responder. You know, I'll put on 11 pounds and 10 pounds on 10 grams, and I just don't need that extra weight. So it's been challenging to balance the right amount.
Yeah. And at the ISSN, I'm going to try to break it up with some strategies to help decrease that, you know, maybe acute water retention or weight gain. And now we're looking at some studies with multiple smaller frequent dosages. And the 10 grams, in my opinion, it seems to be hitting the whole body. But Serge has put out some few papers if you're looking at it from a cognitive perspective, and 4 grams can get into the brain if you're, you know, over time. But I still would probably say from a simplistic standpoint, 3 to 5 grams, if you say, hey, I'm taking this for the health benefits, that's still going to be viable. My guess is it has to eventually accumulate in the bone and brain to give you those benefits. And if you're worried about the weight gain and all that, that's why I think the loading phase is probably only for those high caliber athletes, or post-immobilization is some area we're thinking you need a really rapid boost. Obviously, concussion or things like that, you would need something. But if you're, you know, adequate and healthy, I think the 3 to 5 grams, maybe even up to a little bit more, that could be beneficial. I'm always sleep deprived, so I take 10 grams just to hope and pray that it can help out. And I've really noticed it's almost like I require less sleep now that I've increased my dose. And the thought here is it maybe increases brain bioenergetics and it recovers the brain quicker. But if I'm flying to Europe or I just got back from New Mexico, no time change. But I do notice air flight, I get really foggy, and I try to take 10 grams as much as I can. I break that up into 2 5-gram dosages, but you could break that up into multiple smaller or titrate it up. Whatever works for you is great. I think the key is exercise. And if you're having adequate protein and creatine on top, that would be more than sufficient, way more than what the population is getting.
Did this,
and that
I'm sorry.
I just wanted to add that, by the way, if I don't have mercury poisoning, I don't think you can get it because I eat 2 fish meals a day, almost every day anyway. So, and mostly tuna and some salmon and sardines. So those are pretty good, right, Dr. Darren, in their load for creatine?
Yeah, so there's something that's always overlooked, right? We always think of a powder, but you've admitted now you're eating maybe 2 to 3 servings of seafood a day, your natural production in the liver and brain. You may only need a small amount, and then it adds up to 10 grams, right? So it's interesting that we often forget what we're eating and then naturally making. And if you're eating 2 or 3 servings of seafood a day, you could be well rest assured you're probably synthesizing about 3 to 4 grams. And then if you add in a few more, that's going to accumulate over time. And the Holtman study clearly showed 3 grams was adequate to saturate your muscle. Now, the question comes in, do we excrete that extra down the toilet, or could some trickle into your bone and brain? That's what we really need to determine.
Is there data on if you get untrained people and you supplement them with creatine, but one group would resistance train and one group does aerobic training. Is there a difference in uptake into skeletal muscle?
So no study has done that. Bruno Gualiano's has been the closest, but the thought is from Rogers' elegant study in 92, prior muscle contractions will increase the uptake. My guess is actually aerobic might do more because you have more continuous muscle contraction. We don't think it's the load that's causing the transporters to open. We think it's the stimuli from the muscle. So maybe aerobic exercise would cause more creatine uptake. And in his study, to his point, he did cycling. So there goes to show that maybe cycling or continuous muscle contractions is a way to augment it. I always tell people, they say, oh, how much sugar should I put it in protein? I said, you know, the best way to do it is if you exercise. Exercise first, that'll accelerate it in. If you're really worried about boosting it, protein, not sugar, I would go with protein because it's gluconeogenic and you get all the benefits in protein.
Go ahead, Tony.
Now, we know that obviously we would think the type 2 fast twitch would have a greater capacity for uptake. But that said, even with the endurance activity, I mean, the fast twitch are still going to be involved. But would we potentially, do we know, Darren, if we see an increase in that type 1 fiber's ability to pull it in as well? And
you do. You see it in both the cross-sectional area and the increase. Obviously, the greater the demand on the type 2 fibers will have greater capacity to store it. But of course, I'm sure that data is going to be very nuanced now that we know we don't even express type 2X fibers anymore. So our new technology is coming out with having a muscle fiber. And of course, Jose, you can talk about this from your PhD, but now the fiber is hybrid and Winder Wave in Belgium and Andy Galpin says, we don't even have type 2X anymore. I'm like, oh my God, now we're down to 2A. And so all of this is always changing. And we're trying to always give people the best advice to at least exercise first and then try to understand. But you're right, when we start to do biopsies and we're, you know, Mike Roberts, I talked about he comes up about hyperplasia and sarcoplasmic hypertrophy. All of this is coming back to new life because I think with new technology and some advancements in other labs with sophisticated techniques, it's going to show. And can the fiber split? I agree. I'd be shocked if there's not hyperplasia in some of these Olympic bodybuilders, you know, 300 pounds or lifting thousands of pounds. Maybe the fiber just splits and we just didn't have the technology to measure it. And I know from the quail to the cat, why would the human muscle look different? And I'm really excited for the next 20 or 30 years when we start to get all this new data to come out and sort of challenge the central dogma. Yeah, it's going to be fascinating.
You know what's, when you mentioned hyperplasia, it brought up something that I had thought about, which I have no intention of pursuing. It would be hard as hell, but the idea way back when I did some of that work in birds and quail of all things, looking at if there was a critical cell size that muscle cells get so big and then they start to split because you gotta have some sort of diffusion distance, you know, from outside the cell to inside the cell. What about this scenario? What if you were doing regular, pretty high volume, high intensity aerobic training from a young age, you know, and you're competitive. Your cells, obviously, you don't want them getting bigger because you want to decrease the diffusion distance. Would there, and again, I'm just purely making stuff up, would it make sense for them to split so you have smaller fibers that decrease the diffusion distance from the capillary to inside the cell? I'm thinking it kind of makes sense, but it's not a question anyone's ever asked. I mean, I ask myself these questions and I never get an answer. Yeah,
it follows that logic of capillary density, right? You want to have less room for the mitochondria to grab hold of ATP and all that. And if there's less space or more of the organelle, the cell has to work less or more challenging and is more efficient. So yeah, that's absolutely correct. Yeah.
I mean, I don't know about you, Tony, but I ask myself these questions only to come up with no answers.
Well, I say that to my students all the time.
Yeah.
I'm more impressed if you ask the right questions when you leave than giving me the answers, because you know what? Tomorrow the answers might be different. So ask the right questions.
It's funny. It's the more we learn, the less we know.
Exactly.
It's almost like now the answer is, I don't know. It's just, it's becoming so, and it changes every day. Like it's quite fascinating. Yeah.
Now, one of the more controversial issues with creatine is supplementation in children and kids. And just personal anecdote, my kids were young. They played travel softball for not quite a decade. And we gave our kids creatine, we gave them protein, and they actually were really good. I mean, our travel softball team was at times ranked #1 in the country, which, I mean, there's a lot of travel softball teams. Now, whenever the other parents were aware of it, they thought, well, that's kind of crazy that you're giving creatine to kids.
Yeah.
And I know it's difficult to do longitudinal studies on kids, you know, with creatine supplementation. What are your thoughts on that, Darren?
Yeah, I really struggle to understand why a child or anybody can't take creatine for a few reasons. We're naturally producing it. If our body doesn't like it, it'll be excreted in our urine. It's made up of 3 amino acids. And when you look at all the data, especially from Chad and Andrew, and now they're looking at blood biomarkers, I'd be shocked if there's any adverse effects at a low dose. Like if you're saying 3 to 5 grams a day or 0.1 gram per kilogram based on the size, I'd be shocked that a child or anybody can't take creatine because it's naturally produced. It's not a drug effect like a high dose caffeine. So I really do struggle. I understand the caution for sure, just like pregnancy, but it's naturally in our body. And if you take in more, our body just adapts or it gets rid of it. And when I look at all the data, I'm not seeing any adverse effects. And I know Andrew and Chad are actually currently looking at the blood biomarkers right now in children. And I'd be shocked if there's any adverse effects compared to placebo.
Yeah, I mean, if children are eating a lot of fish and meat, I mean, obviously they're getting creatine. So, but I mean, I don't know about you, but outside of exercise science departments, and even sometimes within exercise science departments, but outside of it, whether it's in the Department of Medicine, Department of Nutrition, it's actually quite a bit of a pushback. It's, I mean,
and that's why we got to get these papers out, you know, part 1 and part 2, the misconceptions, and ironically, we'll still be, you know, lectures and whatever it is, and it's almost because creatine was so effective and we didn't have a lot of information on it. People thought it was a steroid or whatever it is, and when it comes in a jug or a powder, a lot of individuals are like, oh, you got to make sure it's safe and things like that. And but it's our job to try to just get out evidence-based research, and what we're talking about comes from laboratories and experiments which are highly controlled. And we've measured liver and kidney function and cardiovascular function in really high dosages. And again, it seems to be the safest, most effective ergogenic aid at normal dosages. The study we talked about in postmenopausal women, 11 grams a day for 2 straight years, and not a single adverse effect more than placebo.
11 grams.
So if you're giving 11 grams a day, that's almost 4 times as much as what's normally recommended for 2 consecutive years, and there was no greater adverse effects. And you look at all the totality of evidence. That's why I kind of put creatine right at the top from a safety and efficacy standpoint.
And that would be 11 grams in, you know, generally probably less body weight than the male. So if you looked at the percentage, you would be saying you're going up to 15, 16, maybe even 17 grams in the male, right? If you equate it for body weight. That's
correct. And the key is that we focus on a population that as we get older, organ deterioration already can occur. And then we sort of saw no adverse effects there as well. And again, monohydrate, it's identical to what's being produced in the brain and liver. The body recognizes it. And to be honest, if you have a little bit of a urinary creatine or creatinine elevated, that's fine. It doesn't cause any pose more stress. And that's why we're super excited to get these myths and misconception papers out from ISSN to sort of tell the public, even in the sports industry, that, hey, we're sort of looking at this from an evidence-based perspective.
Now, I have a question about, this is one of the more common ones I get about pre-workout supplements that have creatine. They're like, well, I read somewhere that caffeine can somehow counteract the effects of creatine. And I mean, I consume a lot of caffeine every day and I take creatine. So I don't know. I know there's that one study, I forget the author, but it was, God, I think it was 20 years ago, even longer.
Yeah.
What are your thoughts on that?
Yeah, so my answer to this has changed a little bit because people sort of went a little bit crazy. It's like the intermittent fasting and killing you the other day. It was on social media. So there's been about 5 or 6 studies done, and 4 have been very cellular. And Peter Hetzpel was the study you've been thinking of. And sure enough, they've shown that if you take creatine loading and then you take a high dose of caffeine, that's not coffee. So
like what would a high dose be?
It was over 300 milligrams after the creatine loading phase. So in the US, that would be what, a large Starbucks or a medium Starbucks, maybe, that you would find 300 milligrams in coffee, maybe.
Right.
And they've shown that they do oppose each other at the sarcoplasmic reticulum. However, when you look at the other studies, if the dose of caffeine is lower than maybe 200 milligrams, which is the average coffee, there probably is not going to be an interference effect. To your point, we're actually doing this study now because people think caffeine is coffee, and we're actually looking at creatine in different dosages of caffeine in black coffee to see does it interfere. My thought is I try to split it up just because we don't know. So I do pre-caffeine workout and like in coffee, and then I'll take creatine at the other times of the day because really the timing doesn't really matter. But if someone says I can only put my creatine in my cup of coffee, I'm like, go ahead. That small dose of caffeine and you take it really acutely is probably not going to interfere. For those taking a pre-workout, by the way, there's a lot of other things in that compound. You're never going to know what's working. But if it works for you, great. I think a lot more long-term data needs to be done. But if you do look at the data, they do seem to oppose each other from a muscle relaxation standpoint. We don't know, does it impair muscle growth or strength?
Which is really what almost everyone.
That's what everybody's wanting. Yeah.
Yeah. So as long as my lean body mass goes up, who cares about muscle relaxation, right?
Yeah. At the end of it, if you had to choose two ergogenic aids for performance, you got to put caffeine and creatine right up there. Protein is sort of the staple of everything, beta alanine and bicarbonate and beetroot juice. But if you're looking for performance, creatine and caffeine are pretty much neck and neck when it comes to performance. Protein does everything, and creatine kind of has a multifactorial approach. But for those interested in caffeine, we just put out that phenomenal paper and we answered and addressed a lot of questions. And at the end of it, it's funny. There's only maybe 5 to 10 things that seem to have good evidence that work, but a lot of other things don't. And that's why some of these influencers or podcasts and some of these talk shows that are promoting things that everybody knows doesn't work. And if Huberman puts it on, it's just, you got to take it with a grain of salt to make sure it does work, and it doesn't, right? So.
Well, the saying, it's like simple works, but complicated sells.
Mm-hmm.
So yeah, I would, just like you, I say creatine and caffeine. Those are my top 2. And then after that, maybe throw in some beta alanine, maybe throw in some beetroot or nitrates.
Yeah.
And then it gets kind of tricky. It's like, okay, you could do carb intake maybe during a race, or if you need the glycogen load.
Absolutely. I've never taken beta alanine or beetroot juice and stuff, but you can get a lot of that through the type of foods. But it's sport specific, right? It depends what you're trying to achieve. Yeah, for sure.
Now, you recently, I think it was this year, there was a paper. You were an author on it dealing with hemodialysis patients, which I thought was interesting because when I think of creatine, I'm not thinking of hemodialysis patients.
Yeah.
I mean, there are clinical issues that they just don't jive, but someone thought about it, and tell us a little bit about that study, because it's something I would have thought of.
Yeah, long-term study, clinical population out of Brazil. And one of the big caveats of hemodialysis is the substantial loss of muscle mass and strength. So creatine could overcompensate some of those negative aspects, very similar to sarcopenia, and it had some profound beneficial effects there. No adverse effects on the kidney even further. And again, so there again, we're starting to branch off into the health aspects for clinical populations, which is a big area to move forward. Yeah.
So there were no untoward effects on renal function, liver function.
Nothing. Yeah. And it was the dose. I can't recall right off the top of my head, but the dose was within the recommended average for sure.
Yeah, that's interesting that you're seeing a lot of the really cool research being done clinically. It's, I've always thought, okay, if you need a master's thesis, just do something on creatine. We know it works. However, it's almost gotten to the point, I don't know what you guys think, but it's like, okay, I don't really need another study to show that creatine makes me stronger.
Yep.
I know it makes you stronger. I know it'll increase lean body mass. I mean, obviously there's going to be some variation, but some of this clinical stuff is really kind of cool.
Yeah. Oh, Tony's on mute there, but it's become almost more health aspect type of compound that we're looking forward to. And in my talk at ISSN, that's probably I'll focus how the evolution is quite changed, and it's quite. We hit the roller coaster, and now we're sort of having the momentum again. So that's really, really good. Yeah.
It would truly be the wonder supplement if it decreased the risk of cardiovascular disease. Imagine that, Tony. It's like decreases risk of CV disease. It's like, okay, what, there's a running joke, at least amongst a lot of my friends who I'll see here. It's like, okay, what doesn't this stuff do? Does it treat ED? I don't know.
Yes.
Does it, Tony? ED?
I get that question almost every day. What doesn't it do? And because it's quite shocking, some of the things will come out, and I'm like, take it, if it's in a rodent model, or, it's extrapolate, but we got to have these long term. And then, some surprising, maybe didn't have the promise for the neurophysiologicals like Parkinson's and MS and things like that, but more research on concussion and things like that. So it's really going to be something to consider. And I think the neck up for the next 20 or 30 years, sleep deprivation, hypoxia, mental acuity is huge. Yeah.
Tony, how much of this is known in the fight world in terms of creatine and, sort of as a prophylactic for, treating brain injury?
Yeah.
Oh, you're muted.
My apologies, gentlemen. We've had some technical. You can hear me now, correct?
Yeah.
Okay. Yeah, I think we're getting there. I think that regarding that, I think the UFCPI has made this, relatively well known, at least in a smaller circle of the combat world, because they have the opportunity to converse with these fighters, see them with great frequency, and have that kind of an impact. So, of course, Charles does wonderful work there. He's certainly making sure that fighters are cognizant of the therapeutic benefits regarding the trauma, and not only that, potential cognitive performance. But I think in wrestling, I think Joey and Darren would probably be at the collegiate level. If you're at the Penn State level, you're probably learning about this, because you're going to have the best RDs, you're going to have great staff, you're going to have great athletic trainers, you're going to have physical therapists and strength coaches telling you, hey, providing you can still make weight, let's get this creatine in. I think the UFC is making some advancements now because of the performance institutes. Now, if you go back to sports such as kickboxing and boxing in itself, where there's really no central, if you will, medium in order to dispense information like that, it's probably still well behind.
Yeah, I get calls quite a bit, even from the National Hockey League recently, and I was shocked that not all athletes have even heard or considering it. And we always think we're doing a good job promoting it, but to your guys' point, a lot of people just don't know. And you would think at the professional athlete level, especially with the Olympics coming up, if something can help and it's approved by the IOC, it's safe and effective. But it's shocking to me when people say, "Oh no, we just eat whatever we want," and I'm like, "Oh wow, that's kind of could be the big difference between a gold medal and a silver, or not even placing," and it's a big issue. Yeah.
Yeah, and not just in the fight world, but in the endurance world.
Mm-hmm.
At least we know bodybuilders, powerlifters, they're cognizant of creatine intake, protein intake, and whatnot. And as you well know, in the endurance world, it was very carbohydrate-centric for many, many years. And convincing them to at least consume protein, extra protein to promote recovery, that by itself was really quite a task. Now, we're telling them to take creatine. They're like, oh my God, you're just convincing about protein. I don't know if will this slow me down? And like, for instance, my wife is a national class cyclist, and I have her on every supplement known to man, including a lot of creatine. But when you talk to cyclists at these races, they're like, well, I just eat food. And I'm like, okay, well, that's good. I mean, we'll keep the advantage. You guys just keep eating food and don't take supplements.
Yeah, I think one of the most interesting findings was the benefits of creatine on long duration cardio by decreasing inflammation post-exercise. Those cytokines were really suppressed. And when you look at the mechanisms of creatine from being an anti-catabolic effect, any athlete that needs to train multiple times a week leading up to it, it seems to have a lot of recovery, not just growth perspective. So that's why in that paper for soccer, swimming, long duration, like triathlon, Ironman, when you're putting your body through hell for hours on end, this is where this compound can really help from a recovery standpoint. And of course, protein has to be elevated for the recovery process. But when people say, I just eat food, I'm like, well, you're probably getting a lot of this anyway, but it's okay to have a little bit more education on what might even help you a little bit more. Yeah.
One last question, and then because we're running out of time, and this is, again, sort of a controversial area. creatine supplementation during pregnancy, the effect on the child.
Yeah, so
Hard to do a human study. I mean, and honestly, I'm not sure how much, how much I could put into animal data. What are your thoughts on that?
Yeah, so Stacey Ellery in Australia leading the charge here, and she's put out some good proposals or review papers, and they use the animal model primarily. And there's been a couple of cute, well-supervised, medically supervised studies looking at some brain bioenergetics in the developing fetus. So as it currently stands, medical caution is highly advised. We don't know if creatine is going to get in the breast milk. We don't think so. But the theory of the oxidative stress and the high bioenergetic demand for not only the mother, but the fetus, and creatine works exactly the same way for brain bioenergetics. It could have some potential for decreasing some abnormalities. But I would say, again, just like the neck up, that will be a focus for the next 20 or 30 years. When you read all of Stacey's papers, it seems to be very safe at a low dose if it's monitored. But again, a randomized clinical trial, which is the gold standard, it's not the meta-analysis, it's the RCTs that sort of drive all these reviews. Yeah. Those need to be done with an adequate sample size and medical supervision. And the question often gets asked, can I take creatine during pregnancy? And when I always put it back to those articles, I say, as it currently stands, the answer is yes, but please talk to your doctor to make sure that it's safe and effective for you. Please start at the lowest dose and then question yourself, why are you even taking it? Is it for the child? Is it for you for whatever reason? And again, the caution is there, just like children, but again, it's naturally produced and we can see why there's potential for it. Yeah.
Yeah, and I would imagine one way to sort of get around the creatine supplementation would be to have pregnant women consume a lot of fish. Now, I don't know how much fish that would be, but I would imagine it's a lot of fish.
Yeah, and I mean, 1 kilogram of meat is about 5 grams, right? So if you're having 1 or 2 servings of seafood in your natural production, it could be elevated a little bit. And again, this is the area I think will be a real big push in the industry from the health aspects. Yeah.
Okay,
yeah, and just quickly, no, Joey, that's a great recommendation. But then a lot of physicians want the pregnant female to avoid a lot of seafood, or certainly a large cross section of it due to the potential mercury implications. Yeah. But that would be a great option, assuming you're getting high quality seafood. Yep.
Yeah, absolutely.
Exactly. Now, before I let you go, Darren, I do want to mention the ISSN conference. It is June 18 to 20. It's in Bonita Springs, Florida. If you need to fly in, you're flying into Fort Myers. The initials for the airport are RSW, so just keep that in mind, RSW. And Dr. Candow will be giving the Harris-Haltman keynote lecture, so everyone will be there. So, Darren, you got to razzle and dazzle the audience because this will be all over social media. So give them good sound bites. They're going to want sound bites.
I'll do my best. I can't wait, and it's a huge honor. I can't thank you enough. Yeah.
Tony, any final words?
No, just always. I learn a lot, Dr. Darren, and I appreciate that. And it's fantastic. We got a great molecule here, so I hope we can make more people cognizant of it. Hopefully we'll have a topical one day and I could just rub it on me.
That's right. It's probably coming, to say the least. Yeah.
Right. Hey, gentlemen. Hey, thank you for being on the show. Dr. Candow, I will see you in South Florida very soon.
Absolutely.
So,
Thanks so much for having me on. It's always a pleasure.
Thanks.